This presentation is about how the brain learns. And so the first thing I want to do is make a little drawing. And I want you to think about what you think I might be drawing here. I kind of gave you a clue already. And this is a neuron. It's a brain cell, spelled N-E-U-R-O-N, brain cell. You have approximately 100 billion of these in your brain. Last count officially was 89 billion, but you know, they have a little bit of trouble counting them. And if you look in a biology book, they will start to tell you that this is a neuron. It has a soma, which is the body. It has a nucleus. It has these extensions that grow that are called dendrites. It has this axon that carries messages down that is protected by a myelin sheath, kind of like an electrical cord. Can you imagine if you had an electrical cord and there was no rubber on it and you plugged it in? The sparks would go everywhere. Because of the myelin sheath, the sparks don't go everywhere. They travel down the axon to these little boutons that shoot out chemicals. And that biology textbook will tell you that a neuron fires and then it rests, fires and it rests. And what happens is the potassium and the sodium get out of balance. And it has to recover from that so that it can fire again. And they give you all that technical stuff. But you know what they forget to tell you? These dendrites, these extensions that you see growing here, are knowledge. Every time you do anything, think anything, and learn anything, they bud, just like the bud on a tree. And they start to grow. And they get bigger and longer. Every time you repeat the information, they get stronger and faster. Now, last I heard in the research was that it took about 2 days for a dendrite to grow. Hence, watch out for summer school when you don't get 2 days to absorb everything. The only way you can make up for not having 2 days is to do extra repetition to force those dendrites to grow. Now, I'm going to use a really simple example from math just to demonstrate some of the things about the neurons. Let's say that I teach you that 3 plus 4 equals 7. It is possible to memorize that without understanding a thing about addition. You can repeat stuff 200, 300 times, maybe only 50 times, and you can learn that fact. And if you do, you can grow a dendrite. Let's make this the 3 plus 4 equals 7 dendrite. The problem is, if all you did was memorize and you have no understanding at all, it will only fire if it hears 3 plus 4 equals 7. If I turn around and give you 4 plus 3 equals 7, it may not fire for you because it doesn't know those are related to one another. So it's real important that you have understanding. If instead you understand addition instead of just memorizing, and you have a concept of what addition means, you can grow a dendrite that is for addition. And the beauty of that is, every time you add any numbers, it will fire. And it will get stronger and faster. So the most critical thing is don't just straight memorize. It won't get you anywhere. Now this happens in math a lot. Students memorize procedures and they go, well, when I see that, this is what I'm supposed to do. And you got to be careful about that. But let's say you manage to learn 3 plus 4 equals 7 and you have a dendrite grown. What if a couple weeks later I come along and I say 7 minus 3 equals 4? Some students may start over again and memorize again. Now, if all you do is memorize and you get 7 minus 3 equals 4, the issue is, where will that knowledge go? Well, if you don't see the connection, it could end up way over here on this other neuron. Now, it's not horrible. It's in your brain. The problem is that when you sit down to take a test and they give you all the different types of problems, your brain has to jump all over the place looking for the information. And if it can't find it, the brain freezes up, it goes blank, and anxiety kicks in. And then you have trouble doing your work or passing the test. So the smart move is to look at those and compare them and say, hold on a minute. 3 and 4 make 7. Obviously, if I remove the 4, I'm back to the 3. If I remove the 3, I'm back to the 4. These two guys are related to each other. If you do that, the dendrites will grow right next to each other. And they will fire together, and all that information will be available to you when you're working your math test or whatever. A couple other things to tell you. At the end of the neuron, the dendrites, each neuron can produce 10,000 dendrites. So imagine 100 billion neurons with 10,000 dendrites. Massive amount. The other thing to let you know is they're very particular, they're very selective. If this neuron decides to be a math neuron, you can't go home tonight and study Spanish and grow dendrites there. It just won't happen because it is reserved for math. Now, if you memorized and you don't really know where the concept fits, they might get jumbled together on the same neuron. So it's critical that we don't just have people memorizing details, but they have to see where it came from and where it goes to. So here's my math neuron, and it's not going to do anything except collect math facts for me. And every time I go back and revisit this topic, it's going to fire and they'll get stronger and faster. I just want to tell you one more thing about the neurons in general. One of my favorite pictures from one of my neuropsychology books, or neurophysiology actually, they had a neuron taken from the brain of a woman who was deprived. She was locked in a closet, was not allowed to go to school. Don't know what her problems were, but the family would not let her socialize at all. And she had passed away, and they donated her brain and her body to science. They had a picture of a neuron from her brain, and it looked just like the one I drew up here. You could count literally every dendrite. Some of them were a little bit longer, but you could count them. On the same page down below that, they had a neuron taken from Einstein's brain. Guess what his neuron looked like? I can't even get them all up here. Got the idea? What we want is to be somewhere between those two. Every time Einstein was told anything, he connected it to knowledge he already have. Dendrites grow on similar related dendrites. New information gets attached to old information that you already know. So it's critical that you always find connections between things. And it's critical that you do a lot of repetition and that you identify what topic it needs to go to so that the brain knows where to put it. That's one of the reasons that when we teach someone to read a textbook, we tell them to preview the chapter. Flip through, look at the headings, see what's being covered in that chapter. Because if you do that, you're priming your brain and you're telling it which neurons to head toward so that it can place the new dendrites in the proper spot. And then it'll be able to find them again later.